All right, have your homework out if you would please, and your books open to page 307. Homework out, books open to page 307. You did numbers 5 through 10. You did 12 to 38, just the evens, and then 45, 47, and 49. Let me go and take a look at that very quickly. There's the 5 through 10. There's 45, 47, 49. And there's the 12 through 38. Okay.
Yeah,
We're kind of doing some things backwards there, but it works. Okay.
Oh, because my notebook is open in front.
Gotcha.
And I didn't remember.
Okay, well that's okay. That's why we're reviewing, right? Because this will help
I
you
worked some of the problems
on the paper. Okay, let me come back and look at that in just a second. I think most of them done there in the book. Very good, very neat. Work there, Joshua.
Not very neat,
Well, hopefully you can read it. Yeah, well, honestly, this is not, as I said before, this is not a work text, so it's best to not try to do these in the book. Numbers 5 through 10, though, you could have answered these in the book. Rational, irrational, and not real. Well, rational class means it works out evenly. For a root, at least. For irrational, that means the root does not work out evenly. And what is this not real business?
It doesn't, you can't.
It doesn't exist. And what's the only case we talked about where that happens? Square root of a negative, right? So, number 5 class? Rational. It's just 4. Number 6?
Irrational.
Yeah, you can't take the square root of 91 evenly. Square root of 100 is 10. Square root of 81 is 9. So I know this is probably like 9.5-ish, but it doesn't work out rationally at all. Number 7? Irrational. Again, and we could reduce it to square root of 5, but it's because it's irrational. Number 8? Not real. You cannot take the square root of a negative. Number 9? Irrational, again, doesn't work out evenly. It's a little over 4, right? We know the square root of 16 is 4. Square root of 70 is like 4.1, something like that. But it's a decimal that keeps on going forever. And number 10? Rational. That works out evenly. It's 2. All right, does it make sense now after reviewing over those? All right, let's take a look at the 12 through 38, the evens now. Number 12, we were simplifying the square root of 80. And square root of 81, rational. It's 9. Square root of 80, irrational. But I can reduce it if I factor the 80 into, Joshua?
16 and 5.
Good, 16 and 5. If you did 4 and 20, just make sure you factor the 20 again. We end up with?
4 times the square root of 5.
Great job. Number 14, we have 7 times the square root of 54. Ignore the 7 for now. Focus on the 54. How will we factor it, Dylan?
9 and 6.
If it were a cube root, it'd be 27 and 2, but it's a square root, so 27 doesn't help. I need the 9, like Dylan says. We'll take the square root of the 9.
3.
Times the 7 now that was out here.
21 times square root of 6.
And there's our answer. How many had that for number 14? Number 16, we have the cube root of 128. Adam?
You take it by, let's see, wait, hold.
Lana?
64 times 2.
64 times 2. Now, you would do this if it were a square root as well, because you would take the square root of 64. In this case, it's a cube root, but 64 still works because you can take the cube root of 64, Lana.
4
times the cube root of 2, and that's the answer we should have had. How many had that for number 16? So you didn't have that. You were just trying to remember how you did it.
Yeah, because the 14, I don't know what happened, because I didn't seem to have an answer there.
Okay. Careful there. Number 18, we're going to come back to Adam. And this time, Adam, it's very similar to what we did before, but with a bunch of letters in there. We've got all kinds of stuff going on here. That's it. I'm out of order here. All right, let's try that. A, B, C, D, not A, B, D, C. Anyway, so Adam, we're going to start with the 32, and we're just going to factor it.
16 and 2.
If it were a square root, yes, but I can't take the cube root of 16.
The 8 and 4.
8 times 4, there we go. Where I'll take the cube root of the
2. 8.
Of the 8 to get a 2. And for now, we'll leave a gap, and we'll also put the cube root of the 4. Now we come to the letters, and it's all about asking ourselves, how many times does this go into that? Because we're dividing. How many times does 3 go into 5?
Once.
With?
2 left over.
So I'm going to write?
A squared.
Good. Once with 2 left over. 3 goes into 7?
Twice.
So b squared with?
1 left over.
3 goes into 9?
3 times.
With?
None left over.
Okay, and then 3 goes into 3?
Once.
With?
None left over.
None left over. And there's our answer. How many had this answer on number 18? Handle the letters well. Good. Questions on that? All right, that was our first big focus in this chapter, was just reducing radicals. Then we transitioned to using reduced radicals to add radicals like we see in number 20. 3 times the square root of 2 plus 3 times the square root of 18 minus 5 times the square root of 8. But you said we can't add or subtract radicals unless they are like or similar, which means same index and same radicand. Well, they all have the same index, but ain't none of the same radicands. Josh, help, what do we do?
You reduce, well, like factor the 18 into 9 and 2, and then take 3 times the 3, so 9 times the square root of 2, and then factor the 8 into...
Don't think about this too hard now.
4 and 2.
4 and 2, right? And you're spending all your time trying to find it in your notes instead of just doing what you know, right? Square root of 4 is
2.
2, and of course we're going to multiply that by that negative 5.
Negative 10 times the square root of 2.
And we're going to leave this 3 square root of 2 alone here at the beginning. Now we can combine it all together, Josh, to get?
2 times the square root of 2.
Great job. How many have that for number 20? Number 22, we have a 4 times the square root of 80 plus a 6 times the square root of 45 minus a 2 times the square root of 20. Dylan?
Factor the 80 into 16 and 5.
Yeah, we'd already done an 80, so we already know 16 and 5 from earlier. Out of the 16, take out a
4
times the existing 4.
16 times the square root of 5.
Again, he's not pulling the 16 out. He's pulling a 4 out. But since there was already another 4 there, 4 times 4 gives us that 16. Here on the 45 then,
9 and 5.
9 and 5, pull out a
3.
times the 6.
18 times the square root of 5.
And then at the end,
4 times the square root of 2. Negative 4 times the square root of 5.
and we combine it all together, we get
30 times the square root of 5.
30 times the square root of 5. How many had that answer on number, whatever that was? Number 22.
22.
All right, questions on 22.
Is that wrong?
Oh, okay. Let's come to number 24. And I've got on 24 a radical expression outside parentheses. And there's a bunch of stuff going on inside. What do I need to do anytime I see something outside parentheses and then stuff inside parentheses? What do I need to do here? Adam?
You need to distribute.
Yeah, we need to distribute here. Now, it's not the only way to approach this problem, but I think it's probably, well, actually, I don't know if it's the best way. Because every one of these reduces, right?
Yeah.
This one doesn't. So we could distribute, and then we could do all the factoring. It might be easier to do the factoring first, because 8 is easy.
4 and 2.
4 times 2, and then the 18 is easy.
9, 9, 9, 2.
And with the help of a 4 times 2 and a 9 times 2, maybe we figure out 98 is?
49 times 2.
49 times 2. We're going to pull out a
2.
times the 3,
6 times the square root of 2.
pull out a
3.
times the 2,
6 times the square root of 2.
and pull out a
7.
to get
Negative 7 times, negative 7 times the square root of 2.
There we go. And rather than doing the distribution, which normally I would, to be fair, here we can actually combine all of these together first.
12. 5 times the square root of 2.
5 times the square root of 2, and then we can multiply the 3 square root of 10. Now, once I multiply now, Adam,
15 times the square root of 20.
but I'm not going to leave it like that because I do one more reducing. That would be the only upside of distributing first, is you only have to do 1, 2, 3 reducings. Here I'm doing 3 reducings, and there's going to be a 4th one here, but the reducings were easier. The 20 factors into
4 and 5.
where we pull out a
2.
to get,
30 times the square root of 5.
and there's our answer. Again, not the only way to do it, but I think maybe the easiest is to do those reducings up front. How many have that? You worked it all the way through.
Wow.
Outstanding
Except I did
questions.
it
I
not
had that,
harder.
but I-
You did it the
I
distribution.
distributed first.
Yeah, that's what I would see naturally. And then I start, my brain's like, wait, 4 and 2, 9 and 2, 49 and 2. Oh, I see what we can do here. But yeah, so I mean, 9 squared of 80, 6 squared of 180, negative 3 times the square root of 980. And then as you work it down, you end up with 5 times 16, 5 times 36,
I didn't.
and 5 times 196.
196.
Yeah, 196, so 14 squared 5. Yeah, so it would have worked the other way as well.
So, both of them were 30 times the square root
Well,
of
of course,
5.
there's two ways to approach it, but it's the same problem, so it has to have the same answer.
The answer before that was too.
Yep. All right, let's take a look at the next one here. And they might have been going for distribution there, actually. It just, we found another way.
That's
Look at this problem here, and what am I going to have to do with something like this, Lana?
no foil.
Foil. Now, they're not all similar binomials, right? So it's probably going to be an FOIL, four separate terms rather than some combining. But the first gives us
6 times, or why did I say 6? I was 21 times the square root of 6.
there we go, the outer,
Negative 7 times the square root of 4.
the inner.
8 times the square
Ooh,
root.
careful, 5 times 3.
Oh, 15 times the square root of 24.
And then
I
my
had
mass.
that, but negative 5 times the square root of 16.
Now, two of these radicals, class, are rational.
The
4 and
4 and 16.
Square root of 4 and square root of 16. Lana, square root of 4 just becomes
2,
2. Square root of 16 just becomes...
4.
So really, Lana, this becomes...
Negative 14, negative 2.
And this becomes...
Negative 2.
And those can combine because they're just regular numbers.
34.
Negative 34. This 21 square root of 6 I can't do anything with, right? Square root of 6 isn't going to do anything. But right here, I could factor the 24 into,
4 and 6.
pull out a
2.
times the 15.
30.
Oh, wait a second. I was a little premature here. 30 squared of 6 can actually now combine to get...
What did I have? 51 times the square root of 6 minus 34.
And there's our final answer. Okay, how many got that final answer here on 26?
I think I wrote it wrong because I had 20.
I actually got
not 30.
All right, questions?
See, I get it all right on the homework, but then the
And then
quiz.
the 10.
No,
they're
like,
like,
it comes to the quiz and it's like,
Made a billion mistake.
Okay. All right, well, let's take a look at number 28 then. We had an x plus 3 squared of 2, quantity squared. How do I square a binomial, class?
square the first, square the last, multiply and double.
Yeah.
Multiply and double, yeah.
It's stuck in my
Or
head.
I could write it twice and I could foil. Let's try square the first, square the last, multiply and double. Yeah. Square the first, class.
X
X
squared,
squared.
When we square the last, I always get what sign?
positive,
I square the 3,
nine,
and I square the square root of 2.
2,
Square root of
No,
4, but when you
2.
square the square root, you get the radicand 2. So really, square the last gives me, class,
18.
18. Then I gotta multiply and double. If I just multiply x times 3 squared of 2, what would I get, class? 3x squared of 2. But then I double, that means multiply that by another 2.
6x squared of 2.
6x squared of 2. And of course, I'll have that positive. And there's my answer. How many had that
I
answer
just
on number
forgot
20?
the 18. Like, I left it 9 times the square root of 4.
I got you. So watch for those rational ones. Okay, questions 28. Number 30, we have a 5 over the square root of 10. We can't really do this, Josh. You can't have a radical in the denominator like that. We've got to take the root, but we got to change it.
The square root of 10 to the square root of 100.
There we go, by multiplying top and bottom by.
Square root of 10.
Good, not by 10, but by square root of 10, so my numerator becomes.
5 square root of 10.
But in the bottom, the square root of 100 is just
10.
thoughts, though. I'm not done.
You can, the 5 and 10 can cancel. 1 and 2.
Ah, so my final answer should be the square root of 10 all over a 2. Good job, Josh. How many have that on 30?
Didn't reduce.
Okay.
Number
Number 32, we have a 3y over 2 times the square root of xy. Can I take the square root of an xy, Dylan? So I've got to multiply top and bottom by
the square root of xy.
another square root of xy in top and bottom. So my numerator becomes, for now,
3y times the square root of xy.
but my denominator becomes,
2 times the square root of x squared y squared.
of course, the square root of x squared y squared is just,
2xy.
yeah, this really just becomes a 2xy, but I'm not done.
You can cancel the y.
And I should specify
Y is not equal to 0.
y does not equal 0. And there's our final answer. How many made it all the way to the end? How many were really close? Just maybe forgot to cancel.
I just forgot to put the qualifying
Forgot
statement.
Oh, just forgot the qualifying statement. All right,
I did
good.
something weird.
Does it make sense what we should have did? All right. Let's take a look at number 34. we've got a 10 times the square root of 5 being divided by a 3 times the square root of 2. Now, there's only one thing in this entire expression that troubles my soul. Class, what is that?
The radical.
Denominator.
Specifically?
The radical.
The square root of 2. The 10 doesn't bother me, the square root of 5 doesn't bother me, the 3 rather doesn't bother me. That square root of 2 is the only issue I got with this expression. So that means I should multiply top and bottom by
Square root of 2.
a square root of 2, so that way instead of it being a square root of 2 class, it's a square root of 4, which would just be a 2. So in my numerator I get, and in the bottom we said we get 3 times 2, which is 6. But I'm not done.
Cancel the 2 to get 5 and 3.
And so 5 times the square root of 10 over 3 is the final answer. How many got to the final answer? How many stopped at 10 squared root of 10 over 6?
No,
10?
I got an answer.
Okay.
10 square root of 5 over 6. That's
Careful. So you multiply the bottom by a square root of 2. Make sure you multiply the top by a square root of 2 as well. All right? Any other questions, comments on that one?
No.
All right, let's go to our next one. We're making our way through these here. Number 36. We have all one big radical this time. We have a 7y over a 12x all underneath the radical sign. But the same thing, I gotta take the root of the denominator. Well, I can't take a square root of a 12, but maybe instead of a 12 class?
144.
36.
36. That puts a smile on my face. Now, 144 will work, but if you look at your answer, you could reduce it more probably. And x? X squared. So how do I make this 12x become a 36x squared?
Multiply by 3.
Multiply by 3x underneath the radical, of course, so that my numerator becomes 21xy. Numerator is going to stay a square root of 21xy for now, but the denominator becomes a nice, easy
6x.
6x. Now, if you did a 12x in the top and bottom, your 84, notice, could factor into 4 times 21, pull out a 2, and cancel the 2 with your 12 to get 1 and 6, and you have the same answer I do. So it's not wrong, it just means a little bit more work for you there. And last of all here on this set of problems, number 38, we have this 2-term radical denominator. Lana, what do we need to do whenever I have a 2-term radical denominator? Multiply by the conjugate. And what is the conjugate here, class?
1 minus 6.
And so in the top, I'm just going to distribute, class.
7 minus 7 times square root of 6.
Yeah, 7 minus 7 squared 6. But in the bottom, anytime I multiply by the conjugate, I got 3 steps.
Square the first, square the last, multiply.
Minus sign between them. No. All right. Instead of yeah. All right, so we square the first class.
1.
We square the last.
6.
We put a.
Minus 7.
And what is 1 minus 6?
Negative 5.
-5, but
Bring the negative up.
bring the negative out front. So -7 squared root of 6 all over 5 should be our answer. How many had that? On number 38.
I did the other process, like I multiplied by the square root of 6.
All right, so remember, conjugate, anytime there's 2 terms in that denominator, right? Questions on that? Step down to 45, 47, 49, and we were solving radical equations. 2 key steps to solving radical equations. Class? Isolate the radical. Square both sides. What are my 2 steps, class?
Isolate the radical, square both sides.
So number 45, the radical's already isolated. So all I got to do is
Square both sides.
square both sides. When I square a square root, I get the
Radical.
radicand. When I square a 3, I get
9.
9. And then to solve for the x, I just need to subtract the
4.
to get x equals
5.
easy enough, right? Number 47, though, I've got to do some things to get this radical isolated. What do I need to do here, Adam?
You need to subtract the 4 to get a 6, and then you divide the 2 to get a 3.
And now that the radical's isolated, class,
Square
square both sides so that my equation becomes, back to Adam,
3x1 equals 9.
and then 2 steps again.
You subtract the 1 to get 8, so then you have 3x equals 8, but then you have to divide the 3 to get an annoying answer.
8/3, right?
I got 2/3.
Oh, 8/3. That's annoying. We could check it if we're skeptical.
It works.
8/3
It's
times
just-
3. The 3 is just going to cancel with the 3 down here, right?
Yeah.
So it really just becomes
9.
8 plus 1.
9.
9 to square root of 9 is 3 times 2.
6.
plus 4?
10.
There's the 10, and it does indeed check out. The other way is to be lazy and say, well, I didn't square a negative, so I'm just going to gamble it's right. All right? And then let's take a look at 49. We have the square root of a 16 negative 3x, all equal to an x negative 2. And anytime I got a radical equation, class, isolate the radical, square both sides. Radicals isolate, I got to square both sides. Here, I'm just squaring the radical.
16 minus 3x.
Yeah, I get the radicand. Here, I'm squaring a binomial.
And
Square the first, square the last,
multiply and double.
Yeah.
and we get
That was the same.
X squared negative 4x negative 4.
positive 4, you said?
Yeah, I said positive.
Positive 4, huh? And
My arrow was
we have a quadratic, which we're going to get to in just a moment. By the way, talk a little bit more in depth. But we got a quadratic set it equal to
0.
0 and
The
factor.
Yeah.
Right, so we've been doing this for a little while here. Set it equal to 0. Remember, the x squared needs to be positive, so I'm going to put the 0 here, leave the x squared, bring the 3x as a,
Positive.
to get,
negative x.
send the 16 over as a
Negative.
negative to get,
Negative 12.
and then I'm going to factor, remember, and I end up with x and x,
Positive.
3 and 4.
3 and 4, so the outer inner comes to the negative x, so two answers for x when I set both factors equal to 0.
Negative 3 and 4.
Negative 3 and positive 4. Let's check the 4 first. 3 times 4.
12.
Negative 12.
16 minus 12.
4.
4. Square root of 4.
2.
2. 4 minus 2.
2.
2.
Let's check the negative 3. Negative 3 times negative 3.
Positive 9.
Positive 9. 16 positive 9.
25.
Square root of 25.
5.
Negative 3, negative 2.
Negative 5.
Oh. One extraneous root, one root that checks. 4 is our answer. Questions on 49. Questions on the homework.
I did pretty good.
No.
Well, let's build on this idea and let's start our last major concept for the school year, and that's quadratic equations. We're going to take a little bit of a deeper look at these here. So next section in your notes, quadratic equations, part 2. We've referenced them, of course, before. In fact, we've been working them off and on throughout the school year, really since the end of the first semester, but they've always kind of worked out the same way. Well, there are some different approaches we may have to take to quadratic equations, but I want to start with some review notes here as we talk about quadratic equations. First of all, what is a quadratic equation again?
Where x squared is the highest.
X squared is the highest power. Write it down just by way of review. X squared is the highest power. And because of the x squared, a quadratic equation is always going to have two roots. Two roots, or two answers. Now, something that we haven't had you put down in your notes before necessarily is what we call the standard form of a quadratic. So if you go and get this down now, the standard form of a quadratic equation is ax squared plus bx plus c equals 0. Now, on the surface, you're like, what in the world is happening here? Descending order of x set equal to 0. Where a, b, and c are just numbers. Specifically, though, a is a positive integer. Remember, I've always told you the x squared has to be positive. Heads off hands. Remember, I told you the x squared's got to be positive? Got to have a positive x squared in proper standard form. Well, a couple of thoughts, though, along these lines. What if the b value right here is a 0? Well, if b happens to be a 0, then that's a 0x, right? Which means no x. No x to the first power. If b equals 0, in other words, if there's not an x to the first power, you've got the square, so it's quadratic, and you've got the constant, but there's no first power x's at all, it's what we call an incomplete quadratic. An incomplete or a pure quadratic is the other name for it. An incomplete quadratic or a pure quadratic. I prefer the name incomplete because I think of Adam like an x squared. He's male, he's powerful. But when God made Adam, he looked at Adam and said, everything else, this is good, this is good, this is good. Adam, this is not so good. No, not him, Adam. No, original Adam. He's like, this is not good. He's alone, he's incomplete. So God provided an x to the first for him.
Oh my goodness.
Right? And so that made him complete. If A and B are both integers, in other words, you have x squared and x to the first, then we have what we call a complete quadratic. Then we have what we call a complete quadratic. You've got the x squared and the x to the first. This would be me for the last 11 years or so. There's me, and I've got my x to the first. You guys right now, you're like the incomplete quadratics. Still searching for that x to the first. Take your time, don't rush. One day, when you find that x to the first, you will be complete. Now, interestingly,
Am I the X?
you will be someone's x to the first one day, we hope. This C thing here, the C is like, kids, you don't have to have the constant to be complete. But a lot of times it kind of comes with the territory. X squared makes it quadratic. If you also have x to the first, it's complete. Frankly, this is what we usually have, right? X squared, x to the first, x gone, and we backwards FOIL, right? This is normally what we do, and I just realized all of these notes aren't showing up on the screen because I was trying to show the poster as well. So hopefully you've been writing off what I'm saying. If not, this is what you should have been writing. Pause the video and catch up for a minute. Sorry about that. But most of what we've been doing, right, we set it equal to 0, we factor completely, we set the factor to 0, we solve. This is normally what we've taken care of, are these complete quadratics. What we're going to look at today is, what do you do for the incomplete quadratics? For instance, write this down, for instance, just kind of by way of review. If I have like an x equals 15 minus 2x squared, is this complete or incomplete, class? This is complete, right? So we want to get it into this proper standard quadratic form, which means I've got to have a positive a. In other words, a positive x squared term. How would I get that?
Bring the 2x over.
Yeah, if I bring the 2x squared over as a positive 2x squared, do you see that my a is a positive 2? Whatever the coefficient of the x squared is, that's my a. Does that make sense? The x can stay right where it is as a positive 1x. By the way, do you see that the b is a 1? And the c needs to come over as well as a negative 15. That's my constant, and it's all equal to 0. So we get it in the proper quadratic form. Once it's in quadratic form, class, we backwards FOIL. We factor completely, right? The 2x squared,
2x
x and 2x, right? The negative sign, positive negative, the 15, 3 and 5, and we check our outer inner. Yes.
Wait, negative.
Because we've got a negative 5 and a positive 6. And so we set them both equal to 0. Now, this is really easy because we just ditched the 3 class and get x equals negative 3. Here it takes 2 steps to get this x by itself. We ditched the 5 as a positive 5, but that's 2x that equals 5. Now we've got to divide away the 2. So it's been a while since we worked on it, came up with a fractional answer. Do you remember doing those though?
Yeah.
It's been a little while. Write this one down. X squared equals 3x. Now it feels like it's incomplete, but it's not. You have the x squared, you have the x to the first, it's complete. And so we'll still set it equal to 0. Which thing moves? The 3x moves to get
X squared negative
3x plus 0.
What does that equal 0? We don't need the constant necessarily, and we don't have one, which means though we're not going to backwards FOIL. How would I factor completely something like this?
Pull an x out.
Just pulling an x out is factoring completely, isn't it? Leaves us within parentheses, class?
X negative 3.
Yeah.
And then when I said each factor equal to 0, well, if x equals 0, x equals 0. There's one of my answers. And if x negative 3 equals 0, class, x also equals
3.
Does that make sense? Moving the lectern all over the place today. Write this one down now, though. X squared plus 4 equals 13. This is incomplete. It's missing its x to the first term. But we could, in some instances, still solve it the same way. We could still set it equal to 0 by moving the, by moving the 13 over as a negative 13. And that would give me x squared negative 9 equals 0. We've done one like this before, but now when I factor. It's not backwards FOIL. It's
Different squares.
difference of squares that needs to factor into a
Sum
sum and difference. The x squared into
X and X.
the 9 into
Positive
3 and 3. And of course, since it's a sum and difference, positive, negative 3 and 3. And we set both of these equal to 0. I'm going to get that x is equal to
Positive negative 3.
negative 3 and x is equal to positive 3. Or in other words, you said it yourselves, positive negative 3. But there's a better, faster, more efficient way to solve incomplete quadratics. In your notes now, incomplete quadratics. And I want you to underline the word I, or the letter I in the word incomplete. Incomplete quadratics, and underline the letter I. Because your first key step also starts with the letter I. For an incomplete quadratic, we're going to isolate the x squared. That's your key step, put a star next to it. Incomplete quadratic, we're going to isolate the x squared. And take the square root. So there's your second step. Incomplete quadratics, isolate the x squared. And take the square root. Write this down. 3x squared minus 4 equals 5. There's an incomplete quadratic. If I tried to set it equal to 0 and factor, it wouldn't work. Set it equal to 0, I get a 3x squared negative 9. I could factor out a 3 to get x squared negative 3, but can you factor an x squared negative 3? No. So what we're going to do instead, we're going to isolate the x squared. I'm going to ditch the 4 instead.
No, positive.
To get?
3x squared 9.
But the x squared's not isolated yet. Now I need to divide away the
3.
3. When I divide away the 3, I'm going to get x squared equals 3. Well, to get rid of a square, I do the opposite of squaring, which is taking a square root. And when I take the square root of x squared, the square root and the square cancel, class, I just get x. Can I take the square root of 3, though?
No.
Not rationally, so I'm going to leave it as the square root of 3, but there are 2 square roots. And it's a quadratic equation, which means I need 2 roots. It's both the positive and negative square root of 3. So one more thing, under take the square root, positive, negative. And that's where we're going to get our second root from, the positive and the negative. Look at page 313 with me, very quickly, as we finish out the hour today. Page 313. Look at number 5. They've already isolated the x squared for me. All I have to do, class? Take the square root. When I take the square root of x squared, class? X. Because the square and the square cancel. But I can't take the square root of 28 any more than I could take the square root of 3. But unlike the square root of 3, class, what can I do about the square root of 28?
Factor into 4.
Reduce it. I can factor that 28 into 4 and 7. So I'm going to leave my answers, plural, as
Positive negative 2 to the square root of 7.
How many remember doing this in Algebra 2 pre-algebra last year? We were actually just doing this, or was doing this about a week ago in pre-algebra. So yeah, this is something we've seen before. Positive negative 2 times the square root of 7. Question?
No, I wasn't here last year.
Well, yeah, you weren't. I guess I was speaking more to them. So in some instances, for instance, remember that problem a moment ago that I put on the board? It was an x squared positive 4 equals 13. And we brought the 13 over, we said it equals 0. Let's do it the other way. Let's ditch the 4 instead, class, as a negative to get x squared equals 9. We've isolated the x squared. Now we're going to
Square root.
take the square root. Square root of x squared? Square roots of 9.
Positive negative 3.
Boom, we're done.
That was
If it worked, now this one was able to be factored, so it worked out to even rational numbers. This one wasn't able to be factored, nor this one. We were able to get either reduced radicals or just radicals. Turn the page. Turn the page. Look at number 15. We have a 3x squared equal to 2. What do I need to do to isolate the x squared, class?
Divide by 3.
Divide away the 3. And x squared equals 2/3. Oh, well. Then I've got to do what?
Square root.
Take the square root. Now, when I take the square root of x squared, class, that just is x. Uh-oh. Square root of 2/3.
Positive
Oh,
negative
yeah.
2/3.
Well, it is positive negative, but I can't leave
Yeah.
that. You have to take the root of the
Denominator.
denominator. Multiply top and bottom by 3 to get the positive negative square root of 6/9, but then simplify to say positive negative,
Root of 6 over 3.
and that's how we'll leave it there. If you end up with a fraction, take the root of the denominator.
Oh, man.
So all these reducing techniques that we were working on earlier, coming back now as we write our answers. We'll stop there for now. So I'm going to make a note where we stopped. I didn't get through everything I wanted to get through today, but that's okay. Let's go ahead
It
and...
took us a long time ago.
It's okay. Not a problem at all. For homework this evening, I want you to do pages 313 to 314. I know we didn't get as much practice in class as I would have liked. Just do your best on these, and we'll take a look at this in our next lesson. But page 313 to 314, do numbers 2 through 20 the even. Page 313 to 314, do 2 through 20 the even. If we do well, wonderful. If we struggle, we'll go over some more problems. And also page 314 in the review. Page 314 in the review, do numbers 3 through 11 the odd. Page 314 the review, 3 through 11 the odd. And that's in addition to page 313 to 314, numbers 2 through 20, the even numbered problems. Have a wonderful rest of your day. You are dismissed.